Hi everyone. Okay, so this is our first look into trig. The problem of the day, which hopefully you guys all did, has you writing ratios of side lengths. And that's basically where trigonometry all begins. Side lengths, the ratios of side lengths. So let's take a look at some of the possible side lengths you probably wrote for triangle ABC. I wrote 8 over 10, 6 over 10, and then 8 over 6. You guys probably have similar. Maybe you also have of triangle ABC 10 over 8, 10 over 6, and 6 over 8. So there's 6 total possible side length ratios of triangle ABC. And then also take a look at these ratios in general, right? 8 over 10, then 10 over 8, 6 over 10, 10 over 6. What do we call these when fractions are flipped like this? Anyone remember? Reciprocals, right? So that's also the same word we're going to use to describe these side length ratios when they're flipped like that. These are reciprocals of each other. Maybe you also wrote ratios for triangle DEF. So perhaps a ratio that you wrote for triangle DEF was 4 over 5. Well, did anyone notice that that's the simplified version of 8 over 10, right? 8 over 10 is 4 over 5. 6 over 10, did we write 3 over 5, right? And notice it's the same connection between the sides, 6 over 10, 3 over 5. Maybe you also wrote 4 over 3, 3 over 4, 5 over 3, and 5 over 4. So those are the total ratio, all of the total possible ratios that you could have written for that problem of the day. But where trig ties in is we know there's going to be tons of triangles we're going to be looking at, but they're not always going to have a hypotenuse of 10, right? They're not always going to have this side length of 8. They could have any side length. So what we are talking about now is different side lengths, different names for side lengths, which you might have seen in geometry. So depending on where an angle is that we're talking about, so we're going to use this Greek symbol theta, okay, this letter theta that we're going to use to talk about that. In this triangle, I'm going to revolve the side lengths around this specific angle right here. The hypotenuse, we know, is always the longest side, that diagonal, that's the hypotenuse. And then there's two other possible sides, the opposite side and the adjacent side, okay? The opposite side is the side opposite the angle. So think about back to Cab, Winnington's room is opposite my room, right? He's across the hall from my room. And then adjacent is right next to the angle, okay? So think about Mr. Donnelly's room is adjacent my room. He's right next to my room, okay? So think about those like ways to remember these. Opposite is across from the angle. Adjacent is literally right next to the angle. Okay, so now let's go back to those two triangles and call this 10 the hypotenuse, okay? This 6, if this is my angle that I'm going to be working with, last time we worked with this top angle, doesn't matter which one as long as we stick to one. So this time I'm going to work with this bottom angle, and that's the angle that I'm going to revolve my sides around. This is theta. So now 6 is my adjacent because it's right next to the angle. And then 8 is the opposite because it's opposite my angle. So now we can go through and say like 8 over 10, well, what is 8 over 10? 8 over 10 is the ratio that represents the opposite side over my hypotenuse. Okay, and that's a more general ratio than saying 8 over 10 because triangles are going to have many different side lengths. But every triangle will have a ratio of the opposite side over the hypotenuse side. And that's kind of what we want to go with here. 6 is my adjacent side, 10 is my hypotenuse. So again, not every triangle is going to have a ratio 6 over 10, but every triangle will have the ratio of the adjacent side over the hypotenuse. Okay, and then 8 is the opposite, and 6 is the adjacent. So now 8 over 6 represents the ratio of the opposite side over the adjacent side. And remember, they are reciprocals, right? These flip. So 6 is now my adjacent over my opposite 8. 10 is my hypotenuse over my adjacent 6. And 10 is my hypotenuse over my opposite 8. Ooh, shoot. Okay, so now there's a name for this ratio. Here's our trig. There's a name for the opposite side over the hypotenuse side, because that's a mouthful. So I said the ratio of the opposite side over the hypotenuse side every single time. So what that is sine trig function. Okay, so here are 3 trig functions. These functions represent the ratios of the side lengths of triangles. So when I have a ratio of the opposite side of a triangle over the hypotenuse side of the triangle, that's called the sine function. So we read it like sine, but I write it S-I-N. Okay, when I'm looking at the ratio of the adjacent side over the hypotenuse side, that represents the cosine function. I read it cosine, I write it C-O-S, like cos, but I don't really say cos, I say cosine. And then tangent function is the function that represents the ratio of the opposite side over the adjacent side. And again, I write it tan, I read it tangent of theta equals opposite over adjacent. So remember, the reciprocals happened when I look at the ratios. There are also 3 more trig functions, which are the reciprocal trig functions. So tangent is opposite over adjacent. I have cotangent, which is adjacent over opposite. Check out the color coding. I have secant, which is the reciprocal trig function of cosine. And then I have cosecant, which is the reciprocal of sine, hypotenuse over opposite. So don't get caught up like these two kind of go together, like tan and cotangent. But like cosine and secant, those words aren't related because they're just reciprocal trig functions. We're going to talk about cofunctions later on, and that's how like these ones are related, and these ones, and then these ones down here. The co, like sine and cosine, secant and cosecant. These are reciprocal functions, so the words aren't really too well related. Okay, guys? How are you going to remember this? Because you need to know that sine represents opposite over hypotenuse. You need to know that secant represents hypotenuse over adjacent. So I'm sure maybe you have heard of SOHCAHTOA. Okay, SOHCAHTOA is how you're going to remember it. The S stands for sine. The O stands for opposite. Let's write this in a different color. The O stands for opposite, and this H stands for hypotenuse. Okay, right? Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Adjacent, hypotenuse. T for tangent, opposite over adjacent, OA. I also write it like this, could kind of get like those ratios a better visual, like sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And you have to remember the reciprocal functions that go the other way. So once you know the first 3, then you just flip it, right? Take the reciprocal of those ratios to find the last 3 trig functions. Okay, so here's your intro. Thanks for watching this video. Click on the next video to check out the first example of how we're going to use these ratios.